This video is going to be about rockets working in the vacuum of space and whether combustion adds thrust, and if so, how much. This page is talking about Isaac Newton's third law. For every action, there's an equal and opposite reaction. So therefore, no air is required to push against. To me, that's kind of like jumping on a trampoline with unlimited springs that just keep going down, 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 and never bounce back up. So it says there's no air for the engine to burn in space, and there's no air for the rocket to push against in space. In spite of what they think, rockets can and do fly in a vacuum. Fuel and oxidizer mix and ignite in a combustion chamber, causing a controlled explosion that is directed out through the engine bell. So that being the case, they must get more thrust off ignited gas than unignited gas. So we're going to put that to the test. We're going to using what we can just to see if there's any result at all from igniting the gas. Okay, so this is our first demonstration, and what we have here is a zip line, basically with a balloon on it, pinched off at the back, and then we have another balloon with just a regular paper to back it up, and it's free to move. See, they're both free to move, and what we're demonstrating here is that you got to have something to blow against. Okay, but if Newton's third law is accurate, then the air coming out the back, that paper shouldn't matter. It should blow anyway. But so let's see what happens when we unpinch the first one. All right. Now let's see what happens when we unpinch the second one. Wah, wah, wah. Our second demonstration, and I want to show the torque you get, or the thrust with a blower. It's like about a 4 or 5 pound blower, and when we turn it on, it'll blow. But if it didn't have nothing to blow against, I don't think it would blow. Or if you put a vacuum on the end of that, or even just a giant nozzle or a bag like I had over the balloon, it's not going to blow anywhere. Maybe I could do that in another video, but I think the balloons kind of proved that. But I like to keep open mind, so if somebody shows me something, something convincing, with showing rockets work in a vacuum, then I'll be convinced. And I'm not saying that there ain't rockets up there. I'm a little skeptical on how high they go, but I'm skeptical about it being a vacuum. I don't think it's a vacuum up there. I think it's kind of like the air is there, but it's just so cold that it's like when you take a balloon, an inflated balloon, you put it in liquid nitrogen, it deflates immediately. The air is still in there, but it's just not showing pressure. So the way we measure the pressure, it's just not there. You take it out of the liquid nitrogen, and boom, it inflates back up. But so this is about a 5 pound blower with going to show the torque it gives, and then we're going to show. I have a 20 pound tank of propane here, and it also blows out, and we're going to see, because this doesn't blow out, it doesn't have near the thrust that this has, but we're going to see if that changes when we ignite it, and see if the combustion adds thrust. So here we go. I'm going to just demonstrate the thrust. So you see that it's pushing. Okay, it's got something to push. That wasn't even on high, so this is on higher. You'll see the push. So it's very obvious, very apparent that the thrust we get when we're pushing on the air. All right. So this is the third demonstration, and this one goes out to roughest. I have a 20 pound tank of propane, and this weighs probably about a third of a pound, this wand. So basically they say that 90% of the weight in the rockets are fuel. Okay, they like to compare it to a gun with a bullet. The gun being the rocket and the bullet being the gas propelled to give you the thrust, okay? So, in my opinion, if you drop a gun, like out of an airplane, and it's free falling and it fires, the bullet's going to go fast, not as fast as if you were holding it, but the gun is going to go, to me that's a good way of describing Newton's third law. The gun is going to barely go anywhere. But they say, okay, so they like comparing the bullets to the gun, but I looked up guns, and to the best of my ability, I found that the average weight of a gun is around a couple pounds, like a handgun. And the average weight of the bullet is about anywhere from 12 to 20 grams. So basically, if you're going to try and use the gun in comparison to the rocket and the bullets for the fuel, then if you loaded about 60 bullets in the average size gun and the average size bullet, then that's what you'd have. You'd have, then your weight would be, you'd start surpassing the weight of the gun. So even if you had 1,000 bullets, just think, you fire them off, it doesn't work any way you add it up. But so what we have here is, so I'm going to turn this on. We're going to see if the combustion adds that much more thrust, because they say that there's a chamber. We know that you can't get ignition in a vacuum. Okay, Cody's lab did a great job demonstrating that, and so have other videos. But even with sources that have their own oxygen and high explosives, they flat out will not combust in a vacuum. So on NASA's very own website, they say that they do the combustion, that the combustion happens in a chamber. So it's given itself an atmosphere, maybe not as much pressure as a full atmosphere, but either way, it's got its own atmosphere, a combustion chamber, then it expels the gas. So what's the point in having the explosion inside of a chamber just to expel the gas? I mean, is it really expelling faster or stronger? This demonstration will give us clues to that. But so I turn this on. This is hanging by a balance the same way the blower was. So we get a little bit, right? We get a little bit. A little bit of push. That's it. So I let it go out. Pretty much the same push. It's the same push lit as it is unlit. Watch, you won't see it move. Look, it doesn't move. You turn it up. Look, I let it go out. I'll turn it up even higher. Let's see if it jumps when we light it. Not even as much thrust as the blower. With all that going on and all them pounds of thrust, it's barely enough to move this wand that's just balancing. Look, I barely even touch it. Look, that's all. That's it. It's balancing on this thing. So you see the combustion, to be honest, is not hardly adding shit, to be honest. So you be the judge. I'm not beyond being convinced, but I just, like I said, once again, I don't think that there's no rockets up there. I'm just skeptical on how high they say they go and what's up there. I don't believe it to be a vacuum. But I'm not beyond convincing. So to me, it's y'all's play. This is our demonstration. I'd like responses to these 3 demonstrations to be convinced. But the ball's in your court. this is the balloons in liquid nitrogen that I've showed before. And you see when the air gets super cold, it goes down to nothing. The balloons go down to nothing, like the air ain't even in there. But we know that it is, because as soon as he takes it out of the liquid nitrogen, they blow right back up. So, you know, have we ever considered the fact that NASA and other scientists from the way back when just might have been wrong? Okay, because we know it's cold up there. So I'm just trying to throw ideas out there that we can see and demonstrate. If we can't demonstrate it, it's probably wrong. And there's particles up there. There's air's up there. It's cold. So let's go with what we see and what we know. Okay, something's going up there, but look at the time lapse. I mean, how high are these things really going? I understand the way perspective works, and you see a plane going off in the distance. It goes straight down. Okay, the sun goes straight down. It drops off in the distance. The moon, everything going straight, drops straight down. But these rockets, they arc. Now, if they're arcing, it must mean they're changing in elevation, starting to go downward. But, you know, even if they're getting higher, and I'm wrong about that, okay, I think we've demonstrated enough to put the ball in their court on proving that it's a vacuum up there. And it looks like something else. Superfluid, I like to think. I think anybody who's watching any of my videos knows my thoughts on that, but are these things really going up, you know, 250 miles, or I don't know. You be the judge.